For coming here to sleep and to see Kotlin. How many of you have used Kotlin or know Kotlin a little bit in the past? Okay. Android developers here? Right. She saw a couple of Android tracks. There's a couple of talks on Kotlin covering Android as well, so you might want to go to that. I'm not an Android person, so I have very little knowledge of Android. Okay, so to give you a little bit of a background on Kotlin, where it started and where we're going. This talk is mostly going to be coding, but we've got a few slides just to give you some background. So it started in 2010 by JetBrains, which is where I work, and we were at the time. JetBrains has been around for 16 years, and we do different types of tools. Mostly we do IDEs, and then we do teamware tools, and we do some .NET stuff. And all of the IDEs and the teamware tools, which is the server-side stuff, is built in Java. We make IDEs for pretty much any language that's out there, but most of the code is actually in Java. So even we've just created a C# IDE, which is running on the JVM, although that is written in Kotlin. And we were looking for a language because we wanted something that was a little bit more concise, expressive, toolable, interoperable, and overall pragmatic. Now, being more concise than Java isn't setting the bar high, because Java is pretty much as overloaded as it gets in terms of words. And at the time, there was basically two languages that were potential candidates. One of them was Scala, and the other one was Ceylon. Scala we didn't choose for certain reasons. Primarily at the time, and remember, we're talking about 2010, performance was an issue. Tooling was a very big issue. To give you some perspective, if there's about 35 people on the IntelliJ IDEA team, there's about 11 people on the Scala plugin, right? So it gives you an idea of how hard it is to tool Scala. The other option we had was Ceylon, which was fitting very nicely. The problem was that at some point our interests somewhat diverged with Ceylon. So that's when we decided to start Kotlin. And one of our focus was interoperability and tools. Right? We make tools, so we wanted to make sure that the language that we create, that we want to use ourselves, for ourselves, our idea was to stop writing Java, but at the same time, whatever we picked, we didn't throw 16 years or at the time 10 years of code in the bin, right? We're not the startup that can just throw everything away and write the next best thing in Node.js, or sorry, in Go. So what we needed is a language that could interoperate with everything that we had in a smooth way. And that's why we kind of came up with Kotlin. From day one, it was developed under Apache 2 OSS, and it's been on GitHub ever since. The current state we released in February 2016, and that's because we wanted to have a long period of dogfooding, because it's very hard to create a language in the 1.0. You got to kind of more or less assume that you're getting things right. So there was a long period of testing, trialing out, making sure we're not messing things up, and there were quite a few changes along the way. Decisions that were made initially around the language were later revoked or changed or gone in a different direction. Right now, there's about 20 plus developers, I think around 22 people at JetBrains working on it. There's over 100 committers at JetBrains, and it's used in over 10 products now. Right? So our goal with Kotlin wasn't to create a language onto which we can then bootstrap some consulting or training. Our goal with Kotlin was to create a language that we can use ourselves. And our commitment to this language and its future is in the tools. So our bread and butter, which is our tools, is now being written in Kotlin. IntelliJ has parts written in Kotlin. Some of our newer tools are entirely written in Kotlin. Some of the new tools and services that we offer will be written in Kotlin. And as I mentioned, the C# IDE, which we're creating, is actually written in Kotlin as well. And I don't like to name drop, but only if it suits my purpose, then I will name drop. But people normally ask, like, what companies? And these are more or less companies that we are aware of that are using Kotlin that you might recognize. There's way more than these out there. But the ones that kind of look good on a slide sheet are these. No disrespect to every other company that's using Kotlin, by the way. And also, if you're not familiar, how many of you are familiar with Gradle? Right. That took a lot of work, that animated GIF. Gradle recently announced that they're providing Kotlin support. So in addition to Groovy, they're now going to provide you with the ability to create Gradle scripts using Kotlin. How many of you use Gradle? Okay. And now they recommend that plugins are written in Kotlin. So that happened earlier this year as well. Where can you use it? Anywhere. Kotlin is not an application that is not a language specifically around Android. We don't make mobile applications. We make tools. So we created a language for ourselves initially for any kind of tool that we make, but its purpose is industrial. So any kind of application, you can use it. Given that it's compatible with Java 6 and the small runtime, and performance-wise, it's fine in terms of compilation. In terms of runtime, it's the same because it's bytecode. It just translates into bytecode. A lot of adoption has been gained around Android. So a lot of Android developers are using it. Given it's also similar to Java, C#, JavaScript, Groovy, Scala, and every other language there under the sun, it allows you a quick ramp-up time, right? So this is not a departure of saying, I'm going from Java to Clojure, I'm going from Java to Haskell. This is something that you are familiar with, and you will be able to get ramped up in no time. And if you've ever watched Rick Hickey's talk of Simple Made Easy, he says that easy is something that you're familiar with. In his words, Kotlin would be easy, although we like to think it's quite simple as well. And also, given that interoperability is a big factor for us, it allows gradual adoption, and we'll see. So you can actually start to create Kotlin classes in your code or start to create Kotlin functions and interop between Java and Kotlin easily. And you don't have to limit this to tests, which is sometimes where we try and pick up a new language, right, by seeing if we can write tests around it. How can you use it? We've tried to make Kotlin as open and as free as possible. Obviously, our long-term interest is that we continue to thrive as a tooling company and that people use Kotlin and consequently buy IntelliJ IDEA, but it is completely open. So you can use it from a command line, from Maven, Gradle, Cobalt, which is a flavor of Gradle using Kotlin, and if you're still using Ant, IntelliJ IDEA, both the Community Edition as well as the Ultimate Edition, Android Studio, Eclipse, and the only one missing from here is NetBeans. Any NetBeans developers? Okay, well, now you've got NetBeans too. We started the plugin for NetBeans, so we actually create the plugins for IntelliJ IDEA, Android Studio, Eclipse, and NetBeans, okay? You can tell where the features are going to go first, right? But as I said, like it's command line, so you can actually open it up in the command line and write code in Vim, and then away you go, or Emacs. Okay, so let's see some code. Right. Any questions? No? Brilliant. Actually, I can't ask. You don't even have mics, so even if you do, speak loudly. But please, do interrupt me if you have any questions. So I'm going to create a new application here. And you can see that I can select Kotlin. Now, normally I don't do this. I normally use Gradle. Gradle's my default build system. But for demos, this works really nicely. And we'll just create a new app here. New app. And Kotlin comes with a small runtime. It's very small. It's like 900 kilobytes. We try and keep it small, and it keeps the standard library in there, which provides a bunch of additional functionality, which we'll see, such as filter, map, flat map, all of these things. And you can ship that with your you can jar it, you can zip it, you can do whatever you want with it. Hit OK. And now I've got my Kotlin application. I can come here and I can say, create a Kotlin class, and I'll call this GOTO CPH. So I can name it anything I want. And then I can spit out main. And main is basically the entry point to a Kotlin application, right? So it's kind of like in the Java world, it would be the equivalent of public static void in a static class, public static void main. And I can say print line, hello Copenhagen, and right-click or hit run, okay? And that will compile, run. It's got incremental compilation, so the first time, obviously, it's a little bit slow. After that, it becomes faster, okay? And then you can see hello Copenhagen, okay? And that's as far as I go in terms of my live coding abilities goes. So you can actually, I can select this code and then create a message, and then set a breakpoint as well, and then I can debug, and then I see, my breakpoint. I've got the debugger and everything. okay? A couple of things. Obviously, I didn't mention, but Kotlin is a statically typed language. It compiles down to Java and to the JVM and to JavaScript. What we're going to see primarily in this session is targeting Java, but pretty much all of the constructs and anything you see can also target JavaScript. Why did we do JavaScript? Because every language under the sun, again, does JavaScript. If you're not, you don't get into the hipster community. So we had to do JavaScript. And there's some very good use cases for combining Java and JavaScript in a single project. Okay, so let me just to show you how this works, I'm going to go and create a Java class. So I'll call this, for instance, customer Java. And I'll do, for instance, private int ID, private string name, and then create the getters and setters. Okay. Now I'll come back to my GOTO Copenhagen. And what I'll do is I'll say val customer Java equals customer Java, right? So you see that I can compile this and it all works, okay? Complete interop. Notice one thing already, that there's no new keyword in Kotlin, so you don't have to mess around with new. Contrary to JavaScript, we don't use conventions to indicate what a constructor is, so you don't have to make this lower. You can make it lowercase, but we do follow the Java kind of conventions in terms of naming, etc. And then, now watch here. If I do customer Java, I see I get the ID. But the completion also offers me get ID and set ID, right? Because in Java, we're accustomed to get ID and set ID. Get to read, set to write. In Kotlin, we don't have getters and setters as such. We just have properties. So if you're using Java from Kotlin, you kind of follow the Kotlin conventions in how you access objects, functions, etc. And if you're using Kotlin from Java, you follow the Java conventions. So I could actually write, for instance, get ID, and that works, right? And then let's go ahead and introduce this as a variable, and you can see that the ID is kind of saying to me, use property accessor, right? So it does allow me to write it, but I can just use the convention the way that you're meant to use it in Kotlin, okay? Now, if I create a Kotlin class here, notice one other thing, that here I have a main function with no classes, right? So in Kotlin, you have the ability to have top-level functions, which we'll see later on. So you don't have to put everything into a helper class that is static with static functions, right? And then your colleague puts their functions in an auxiliary class that then you wonder where the functions are. Are they in the helper class or are they in the auxiliary class? You don't have that issue with Kotlin. In Kotlin, you can just put functions in any file, and then you can figure out where they are, right? Kind of like JavaScript. Instead of searching for classes, you can search for files. But the point is that we cut down on boilerplate code by not having you need to create that classes just to contain some functions in them. By default, by the way, Kotlin uses the package default, but you can say whatever, Hadi Hariri CPH, for instance, okay? You don't have to follow the naming conventions of, you don't have to follow like kind of the death by 1,000 folders in the terms of having everything in that same package, but we kind of do it out of convention. Also, you can have more than one class in a single file in Kotlin. So let me go ahead now. If you see this, right? This is basically 18 lines of code for 2 properties, okay? So let me go ahead and create this now in Kotlin. So I can say customer Kotlin, and I'll create a class. And Kotlin doesn't have fields. Everything is a property, right? So I could just say val ID equals int, and then val name equals string, okay? Ignore that for now. Actually, let me just create this as var, and that way we won't have that issue. Okay, this is just saying it's not initialized, but forget it for now. So here, the convention that we follow in Kotlin is the name, colon, and the type. So if you use to Pascal, it's the same concept. Var means mutable, val means immutable, or read-only, right? By Kotlin, we don't enforce immutability, but we kind of recommend it. And you'll see that we've got interfaces over Java collections that have mutable versions and immutable versions. But I don't want to do it like this. What I can do, in fact, is just declare my properties on the same line as a class. So I can say val id, well, var, because let's do this one, val id int, and then var name string. Okay? In fact, I don't need this open and close either. So that's basically what I've just created in Java, pretty much. Except I've got one additional thing, which is I've also added a constructor, right? So this means that when I initialize my customer in Kotlin, I have to pass in two properties, the ID and the name. But in terms of lines of code, it's exactly the same as this. Well, it's not exactly the same. It's exactly the same basic functionality, except here this is mutable. I've made it immutable. So this would not have its setter. Okay, if we want to make it a setter, we would do that, right? So essentially, I've reduced all of that boilerplate code to something less. Now, fair enough, you'll say that the IDE generates it for me. Yes, we didn't think of that when we're doing this and putting ourselves out of business. But it's pointless. That code is pointless. And the problem is it's pointless not because the IDE can generate it for you so it's not causing you issues. It's that you don't know if the code that you have in 6 months down the line, whether it was generated by the IDE or it has some custom things. It's just more code that is in your code base. Now, I can come back here if I know how to use an IDE, and I can create some other things. For instance, toString, right? And I can create equals and a hash code, right? Okay. So now I've got toString, equals, and a hash code, and now we're at 48 lines of code, right? Okay, remove the white spaces, whatever. Let's go back to my customer in Kotlin and do the same thing. There. Okay? So that now gives me a class with toString, get hash code, equals, and it also gives me something else, which is copy. So if I come here, I can say val customer Kotlin equals customer Kotlin, and then I have to pass a number and a name. Let's call me this. By the way, notice that we also don't have semicolons. So you can use semicolons. If you do, however, you do have to have flame wars on Hacker News about whether you should or shouldn't use semicolons. So I have customer second Kotlin, and I can do customer Kotlin copy, and that will copy that data class for me. And I can override values. So I can override, for example, just the ID. If I do a print line of customer Kotlin, we'll see what that gets me. So you can see that I get a nicely formatted output of what the toString would be in Kotlin. Okay? And all of that is basically by just adding this modifier, which is data. Okay? If I need to, I can actually have, I can override the toString, I can override the equals, I can override anything I want. But out of the box, that's what it ships with. Right? Now, this is good because basically, this code is just typical Java beans that you're creating over and over again. And in Kotlin, you can simply reduce that to a single line of code. Okay. Any questions so far? Yes? The question is how deep the copy goes. So in essence, if I have, for example, a list of copies, if it's going to do a deep copy, I believe no, it doesn't. It just does the top level. Yes, another question. I will get to that in a moment. The question is, how does inheritance with constructors work? So this, what you've seen right now, is basically a primary constructor. What you can in fact do, you can give default values as well to primary constructors. So I can say, for instance, this is 0 and this is empty, right? And that means that right now, I can now create an instance of customer in Kotlin without specifying any input parameters, okay? Initially, we actually just left it at that. But then there were people that said, no, I actually want to have the ability to have secondary constructors, etc. And we'll see how you can do that and then reference the primary constructor, etc. Okay, one other thing that we also have in Kotlin is objects. So I can actually say, for example, object global and pi equals 314, right? Now, notice a couple of things. This is basically how you implement a singleton in Kotlin. right? Because we have the same concepts as JavaScript. JavaScript is a language that just actually only has objects. It doesn't have classes. And then TypeScript came along. We have classes and we have objects. So you can just implement a singleton by just declaring it as an object. And there's use cases apart from obviously just creating singletons. Notice again here that Kotlin is very big in type inference, right? So I don't need to be explicit here. I don't need to say that this is a double, right? I can just say pi equals. As long as I initialize it, it will figure it out. There are cases, for instance, if I do, I don't know, val a long value, and I want this to be long, if I put 10, it will think it's an integer, but we have certain characters that you can use to indicate what this is. In this case, it would be a long, right? And this is a global object, which is fine to use because it's read-only, so I can say global pi, and then just print line this out, and away you go. Okay? Anywhere where that object is declared in the package, it's accessible. Right. Now, functions. As you can see, we've basically created a function, and you can create any other function. So, for example, hello world just takes a message, and then I could just write, for example, print line, right? By default, Kotlin uses, by default, if you don't specify a return type, it's void, which in Kotlin is represented as unit. It's exactly the same as void, except it's an object. So you can query on it. You can say, oh, is this an actual unit, right? And by default, the implementation of toString is telling you that it's a Kotlin unit. If I want to specify a return type, then I just specify a return type. So for example, fun, add numbers, x, int, y, int, then int, return x plus y, right? That's the return type. Now, in cases where Kotlin can actually infer the return type, you don't need to be explicit either, because I could put this all on a single line by just simply doing something like that. So I don't need to open braces, close braces. When my function is basically returning an expression, I can just put it on a single line. Obviously, I can be explicit about the return type as well, but it's not needed, okay? So when you're writing Kotlin, use val var. Don't really do the whole, this is a string, and let me initialize it as a string, and then put some value. Now, if you're doing Java, most of you here are Java or C#, or there's a mix, or Java, C#, okay, JavaScript, and actually enjoy it. So if you're doing Java, you know that Java 9, I think, is going to come up with the whole var, right? And now there's debates, endless debates going on in the community that this is going to decrease readability, blah, 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 blah. If you rewind 8 years ago, we had those same debates in C#, and nothing happened. Everyone continued to write C#, everyone's using var, everything is okay. There has been an increase in people adopting JavaScript, and I don't know if that has any correlation. If it is, then they did do some damage. But otherwise, nothing really has gone bad, okay? So what else do we have? So with the functions, also just like constructors, I can have default parameters, right? And I can have secondary parameters as well. Secondary message, and then I can, use that. And then if I want to invoke hello world, you can see that I just have the type parameter info, and I have the first message, and I can even change the order. So I can say, for example, secondary message equals value, message equals another, right? So you have name parameters, which means you can change the position of the parameters. You have default parameters or optional parameters. And then you can also have an unlimited number of parameters. So unlimited strings, var arg, strings, right? And then I could just write unlimited 1, unlimited 2, unlimited 3, okay? Again, imagine I knew how to type. So that's it in terms of functions, right? It's really, really, really simple. And if you do JavaScript, you see that there is somewhat of a resemblance here in JavaScript, right? Except instead of function, we just write fun. We also have the concept of tuples, except we're limiting it to 2 values. Right? So if you want to return, to 2 or 3. If you want to return 2 values, you could do pair of string, string. Or int, for instance. If you want to return 3 values, you can do triples. If you want to return more values, use a data class. We initially had tuples, we removed it. Because if one of our goals is that conciseness and also readability and expressiveness, once you start to return 7 values from a tuple, you've lost track. Okay? But you can do certain things. So for instance, if I were to call unlimited, let me just remove the parameter here so that we focus on the type. If I say, for instance, val unlimited equals unlimited, now this, I can now do return value first, second, third, right? And the problem there is that you kind of lose, again, the meaning. So you can actually do deconstruction of values. So I can do, for instance, val name, email, and ID equals unlimited, right? And then access the values directly. Okay, so you can do that with pairs and triples. In fact, you can do that with data classes as well. So if I were to take my data class that I have upstairs here, right, which I have an ID and a name, I could do pretty much the same. I could do the ID and the name, and then do customer Kotlin 1 something, right? So you can deconstruct values as well, which gives you that kind of more expressiveness, right? So here again, if I have, for instance, a list of elements or a list of numbers, and here's how you can declare a list of numbers from 1 to 100, which is really nice, it's like Haskell. And I can do for number in list of numbers, and then do whatever I want with the number. And if I'm returning a list of pairs, for instance, I could do the same thing. List of pairs equals list of, and then I can do pair Madrid, Spain, right? Now, you can even do this in a little bit more concise, more expressive way, which I'll then explain to you how it works. But if I could actually write, for example, Paris to France, right? So I'm creating pairs, and I'm mapping. Here what I'm doing, I'm mapping Paris to France, Madrid to Spain. Right? And notice that I don't have to pass in the pair of the string of string, right? The compiler infers all that. So I can do this in the for loop as well and just do, for example, city, country in list of pairs. And then access each of these as well. And to get rid of that potential issue that you have in terms of should I use val or var, will it decrease or increase my readability, you don't name your variables list of pairs, you name them country and city. Okay, there's your readability back. Okay, any questions? Yes.
This looks awfully a lot like Scala.
Yes.
So one of the differences, or I might also ask, when you did this, you said that the reason for not using Scala was it's doing with slow compilation. Why did you just improve compilation of Scala then if you recreated Scala here?
Okay, so the question is, why did you do this if there's Scala, basically, right? Okay. How much time do you... No, I'm joking. The main reason is, or I would say, look, first and foremost, if you are happy with Scala, you don't need Kotlin. First and foremost. One of the ways that I put it is, whereas with Scala allows you to do basically anything. Like you can take any symbol and overload it. You can do pretty much anything with Scala. With Kotlin, you can't. We're purposely restricting the language. We're purposely restricting what you can and cannot do. That gives us better possibilities to tool it. That gives us better possibilities in terms of performance. That's the reason. So whereas with Scala, you might have, for instance, in your company, I do believe that Twitter, for instance, has this, if I'm mistaken, please correct me, they have a style guide of what you should or shouldn't do in Scala. We're trying to get rid of that style guide and say the compiler is telling you what you can and cannot do. So that's basically the best answer I could give you. Another question? Value assertion. You mean kind of like contracts-based? If there is some, not right now in Kotlin itself, no. Okay, so let's move on. I'm sure you're tired of me typing, so I'm just going to switch over to some code that I have prepared. Right? You should have said, no, we actually aren't tired of you typing. You're doing a great job. Just continue doing it. Don't worry, don't worry. Okay, now you know how I can navigate my tree. So what else do we have? So again, I'm going to show you some things in terms of focusing on readability and expressiveness, right? It's a bunch of different language features, but with a focus of why we did it. So here you can see that, for instance, I have conditionals, and an if can be used as a statement or as an expression. So here I'm using if as an expression, meaning that like if the input is greater than 100, print line something and 30. The last line of a if block is the actual return value. And I could, in fact, return here a string. And that works, right? Because now result is going to be evaluated to any. Any is the top level object in Kotlin, right? So I could return different types from an if expression. You can also use if as a statement. If you're using if as an expression, then every branch obviously needs to have some value. The reason for this is that, again, you avoid those intermediate variable assignments, etc. You can just have the expression return a value. The same thing goes for when, and we'll see that a little bit later on. Casting. Now, this is one thing that is different to Kotlin, and some people aren't happy. A lot of other people are happy, so you tell me if you're happy or unhappy. By default, Kotlin classes are final, meaning that you cannot inherit from them. Who's happy? Who's unhappy? Who doesn't give? No, never mind. Right. So if I want to inherit from a class, I prefix it with open. Okay. Now the open allows me to then implement inherit from that class. So here I have a class employee that inherits from person. Right. Here I have another class which is contractor that also inherits from person. Now what is the main difference between a contractor and an employee? Well, to begin with, you don't get vacations. Well, you do. You just pay for them yourself. So here I have a function that is taking a person, and it says if person is employee, person vacation days less than 20. Can you tell me what's missing there? Casting, because the compiler infers it. And you see that it does a smart cast to the actual type. Okay? So it's not a big oh, wow, but it is a big, oh, I just saved myself some typing again. And again, you can say, well, IntelliJ IDEA or my favorite IDE generates that for me. Yes, but it adds a lot of clutter to the code, which is what we're trying to remove as well. Now, who loves nulls? There's always one person. Here is null. Here is Java code, okay? And by the way, this is, if you're not familiar with it, this is font ligatures and IntelliJ IDEA. So that's basically the same as me writing this, okay? If there's no other reason for you to upgrade to IntelliJ IDEA, that should be it. That, and you can put backgrounds, transparent. Okay, never mind. Right. Where were we? Yes. Okay, so here I have a validate customer that's taking in a Java customer because it is a Java class. And I have if customer is not null, if customer get first name is not null, if customer get first name starts with A, names are not allowed to begin with A. I live in Spain. This is kind of the business rules that we have in Spain. Don't ask why. And you can see that I have several levels of nulls because I'm checking continuously about nulls, right? In Kotlin, we don't have nulls. By default, when you declare a variable, it cannot be null. You can create a nullable variable, but by default, it's not null. So if I come to customer service here, this is a customer in Java, but if I write customer in Kotlin, right, you can see that something changes here. This will never be null. It cannot be null. So I don't need to do null checks. If I want to create or declare something that's nullable, I add the question mark after it. That means that this is now can be nullable. If I do that, you can see that the IDE says to me that only, well, the compiler, only safe, which is the Elvis operator, or null assertions are allowed on a nullable type. Which means essentially that I would have to now do something like if customer is not null, then access customer first name, right? But instead of writing that code, you can just use this, right? Which is kind of equivalent to the optional, so to speak. And you can start to concatenate these. The other option is the double hashbang, which says, I don't care, I know it's null, I want to get a null reference exception because I missed those things, so go ahead and invoke it. Why would you use that? There are some very rare cases in which you would use this. Okay, now what happens, I talked about interoperability. What happens if I do this? Notice what happens as soon as I change, right? It goes from cursive to non-cursive. Now that's indicating to me a couple of things, but here, custom in Java can be null. So essentially, this code can throw a null reference exception, right? Now, initially when we did this with Kotlin, we said anything that comes from Java can be null, therefore anything that comes with Java is going to have a question mark, and therefore you're going to have to use a question mark everywhere. And we saw code bases with a lot of question marks, and it looked ugly. Then we decided that, okay, we can make an annotation library which can annotate and infer when the cases are null or not null, and then tell you that in certain cases that question mark is not required. It didn't work out too well either. So then we did what any good consultant would do and say it depends, right? And we leave it in your hands. If you believe that the object that you're getting can be null, add a question mark. If you don't, you do know that you're going to potentially face a null reference exception. So here, Kotlin gives you the ability of any type that's coming from Java that you can declare explicitly as nullable or not nullable. And that also means that, for instance, if you take an interface in Java and you implement that interface in Kotlin, it can use the type parameters, for example, the types that are being passed into the methods that you're overriding or implementing, it can define them as nullable, or you can remove them and say they're not nullable. It's basically leaving it in your hands in terms of when it makes sense to use it and when it's not. Okay, so we've seen functions. Now, no language could respect itself if it wasn't functional, especially nowadays, right? And here, Kotlin is also functional. Now, by functional language, I mean any language that allows you to basically treat functions as primitive objects, right? There is a school of thought that believes that the only functional language in the world is Haskell, and everything else tries to be Haskell. In the context of, can I use functions as primitive building blocks, and therefore that is a functional language, then yes, Kotlin is a functional language. And here's how I declare a higher order function, which is a function that takes a function or returns a function. So here I have a function that takes another function as parameter, which is int, takes two parameters of type int, and returns an int, okay? And then print line function 2 and 3. I'm invoking it. Here I have a function declaration, my sum, x, y, int, return x plus y, which we've seen. If I want to call higher order with that function, I can use it, I can reference it by name using : : Now in JavaScript, that would be just using the function name. Here you have to use : : And you can do the same for instances of classes. I can also use lambdas. I have lambdas in Kotlin, right? And you see that I don't have to be explicit about the types, right? It also, again, infers it. It knows that it requires a lambda that takes two integers and returns an integer, so no need to be explicit. Now we go one step further with the lambdas and do something similar to Groovy. So I can declare this lambda. Notice how it's actually the IDE didn't insert the brackets for me. And that is because we follow the same convention as Groovy, that if the last function to another function is a function, the last parameter to a function is a function, then you can pass that outside of the brackets. In this case, I only have a single parameter, so I can just pass it outside of the brackets. Then I can do this multi-line, right? And now that doesn't look like a function anymore, does it? It looks more kind of like a keyword kind of thing, right? It's like high order could potentially be something that I could add to the language. So why would I do that? Because it demos very well. Here is the using statement in C# that you don't have in Kotlin. Okay? So here I have, in C# you have basically, it's kind of similar to try with resources. I can take a disposable object, you call using, and then make sure that after my using block, it frees that object. And equivalent in Java would be closable. So here I'm declaring a function that takes a closable and then an action that takes no parameters and returns unit. And then I'm going to invoke the action and then finally close it, right? Close that object. So that means that now I could do something like this, using my object, let's say whatever that closing object is, do something with the object, and know that once I'm through with it, it will be closed for me. So I'm kind of like adding micro is a big word nowadays, micro DSLs to my language, kind of extending it a little bit with some functionality. Okay? And we'll see some more examples of this. For instance, if we go to let with apply, you can see a few more. These are part of the standard library. So with file, if is file, what is missing here? What's missing here is the actual object onto which I am calling those methods and properties and parameters, properties and member functions, right? Members. That's what's missing here. I don't need to, because this with function over here is returning that object for me so I can access it inside my Lambda expression. This is part of the standard library. And I'll show you how that's implemented in a little minute, in a bit, because this is called the Lambda with receiver, which we'll see what that is. Another thing that we do similar to Groovy is if the Lambda has a single parameter, you don't need to be explicit about it. You can just use it, right? So refer to it as it. Now we have a bunch of things inside the standard library. So here, for instance, I have data class album, data class track, then list of albums, Dark Side of the Moon with its tracks, okay? The standard library provides me with out-of-the-box functionality such as filter, sorted, flat map, all of these things that you could think of to when you're kind of chaining results from collections, etc. There's also a lot of functionality that's added in terms of strings. So you have, like, for example, insert substring before, etc. Now, the next thing, if you look at each of these, you can see that what it actually is, it uses this syntax of the type. This is how you define a generic type in Kotlin. You prefix it with T and then type, which is going to be generic. There's a dot and there's a filter. What exactly is that? That's function extensions, right? Now, if you're familiar with C#, you know that you will have extension methods in C#, which basically you create a static class and then a static method inside that static class with a parameter this, and that allows you to effectively extend that class with new functionality without having to inherit from it. We have the same thing in Kotlin. They're extension functions. And a lot of the things that you see in Kotlin, a lot of the standard library are merely just extension functions on existing Kotlin and Java types. So here, what I'm doing is I'm extending the string class with a function called hello. Okay? Since I don't have the need to create this top-level class, a static class and then a static method, I could just declare that extension function in a file. And wherever that package is wherever that package is imported, that extension function can be used. So I've just added hello to the string class. I can access the instance of the class that I am extending. So I can do that with this. My extension functions can also take parameters. And you can also have extension properties, not only functions. And now I could do things like this is me, hello. This is Hadi, welcome. Right? Any string class, any string now has my new extension functions. And then you could do funny things like, for instance, fun string should equal, right? And then you put value string, and this returns, for instance, a Boolean, and then you say return value equals this, right? So then I could do something like, this should equal this, right? But Kotlin also allows you to use infix notation when a function has a single parameter or an extension function has a single parameter, a member function or extension function. So I could use infix now, and then I could do this should equal this, right? Again, one of our goals was the ability to create DSLs and nice looking things, and we'll see more examples of this. Okay. If you have any questions, just shout. I'm just... So another thing that we kind of built in Kotlin, delegation, kind of first-class support for delegation. Here I have a typical repository pattern, and the repository pattern, a repository, which is the wrong implementation of every repository out there in the wild, but we've all done it like this, which is get by ID that returns a T, get all that returns a list. This little highlighting here is that it's saying that this could be contravariant. So in Kotlin, we have support for covariance and contravariance. Now I have a controller that is passing in as parameter that repository. Now in a typical scenario, what you would do is you could create this as a property and then do something like repository get all, right? Injecting that dependency in. Here, this isn't a property. I can't access repository because it's not. It's just a parameter to the constructor. You can access it in a constructor block. So here I can access repository, but not in the class itself. But I've added this line here which says repository customer by repository, which is basically telling me that this functionality of the repository is delegated to the repository class that's being passed in. Effectively, what that translates into that I have access to the methods of this interface without having to have a private property to prefix it and use that. So I can just do get by ID and just access any parameter that's passed in, anything that is delegated. You can have more than one delegate. Now the question might arise that if I have 5 delegates, how do I know which method belongs to which parameter that's being passed in response to which I would say invest in a good IDE. Or, better yet, don't pass in 5 parameters, right? If your class is, if you're injecting more than a couple of dependencies, that is a strongly typed, strongly bound class, It's tightly bound, it's tightly coupled, right? Because that class has to be aware of too many things that are going on. It's orchestrating too many things. So there's probably a level of abstraction or something else missing there, right? The solution isn't passing in a collection or just prefixing it. It's just redesigning it a little bit. Now, if you are familiar with Java, you know that Java has streams. Everything that I've shown you up to now has basically been eager evaluation. So, when I do a filter, it's going to list through all of the elements. It's going to evaluate everything. But we also have lazy evaluation. And initially in Kotlin, you would say as stream. But then Java came along with stream, and then we had to rename it. So we called it as sequence. And this allows you to take any collection and do a lazy evaluation. If you can't do that on a collection, you also have the generate sequence function as part of the standard library, which allows you to basically create sequences with a little bit more complex code. Last but not least, how many of you are familiar with Haskell or algebraic data types? Okay, so our implementation of algebraic data types is, algebraic data types basically is a type that could be multiple types. So for example, Boolean can be a true or it can be a false, right? So the way we do it in Kotlin is we use the sealed modifier, right? So I say sealed class, and that basically means that here I have a class page result, and it has a subclass success and a subclass error. As soon as I add sealed to it, it means that there is never ever going to be any other class that inherits that. Right? Which means that I could then do some exhaustive checks on something. So here I'm saying that page result will either be success or error. And again, why would I want to do this? Because again, it leads to a little bit nicer code. So here I have, for instance, a function getPage that returns a page result. And I say if the operation is successful, return a type success. If it is an error, return a type error. Right? Instead of having a single return type that then I have to check for a flag if is error. If it is error, then I have to know by looking at the docs which return values are actually containing the error message, which ones are only in case of successful. I can now have a type return one of multiple types. You could do this obviously without the sealed, but what the sealed is doing is guaranteeing you the inheritance is closed with just those classes that are subclassing it. This is Kotlin 1.0. In 1.1, you can actually put this outside of the class. So you don't need to have those classes inside the class, which means that you don't have to reference them as page result.success. You can just reference them as success. The only limitation is that any class that inherits from your sealed class has to be in the same file. Okay? Any questions? Yes. Yes, similar to discriminated unions. Yes. Well, as I said, in 1.1, you can now get rid of the prefix with the page result, so that minimizes it somewhat, right? And the other thing is, here is one issue, which if this is a sealed class, and if I add, for example, a class, another here, right, which inherits from page result, what would you expect that when to do? Would you expect this when to give you a warning that it's non-exhaustive? It does not. And it does not on enums or on this. And we had it doing it on enums, and we got a lot of complaints. So one of the things that we're looking at is outside of the whole concept of sealed is potentially, and this is just something, an idea, please don't quote me on this, is, he says that as he knows that it's being recorded, is adding sealed keyword to when. So essentially saying that this when is also sealed. Okay? Right, so let me just finish off with a couple of slides. Some other things that people are doing, well, we're doing Anchor is an open source library, which if you're doing Android development allows you to write descriptive layouts without having to use XML, just basically static typed language. Android extensions is the compiler comes with a plugin ability. So you can actually change some things. And what we do with Android extensions is, if you're familiar with Android development, a lot of times you have to do find by view, RID, text view, and then cast it. With this plugin, what you allow you to do is actually reference the type. And one thing that we're also about to release soon is if anyone does Spring. So Spring, one of the issues that Spring developers have with Kotlin is that they have to decorate everything with open. We're going to be releasing a plugin, and when I say plugin, I don't only mean for IDE, but I mean for any build tool, Maven, Gradle, etc., which you can annotate certain classes that say that if they have this annotation, by default, they're open. which makes it, again, more concise when you're writing Spring. Spring Boot, they're good fans, and the Spring Boot already has support for Kotlin, so you could generate your templates using Kotlin. Cobalt, as I already mentioned, is a flavor of Gradle using Kotlin to define builds. Spec is a library, or a testing framework that I've written, which is kind of similar to Jasmine, Mocha, if you're familiar with JavaScript, those frameworks. And the roadmap, coroutines, we're basically implementing a generic coroutine. So in terms of asynchronous programming, we are not going to say we're going to go with the C# approach of async await, or we're going to go with an reactive extension approach or anything like that. We've implemented coroutines, which then we provide a series of out-of-the-box functionality as part of the standard library, which the compiler then transforms into state machines, right? So you can use async await, or you can use yield, or you can use anything you want and not be bound to a specific type. Data class hierarchies, type aliases, deconstructing lambdas, bound method references, delegated properties, local, and Java 8.9. We still are committed to providing Java 6 support, but if you're targeting Java 8 or 9, we will improve in terms of code optimization and certain functionality that is provided as part of the standard library. And JavaScript support. And also, we are now started on native. So there will be Kotlin to native. It's kind of early stages right now, but we've already got something in the works. Next steps, if you are interested, kotlinlang.org. Try kotlinlang.org, which is an in-browser kind of IDE, which allows you to try a series of koans without having to download or install anything. If you want to download, you can do that. They're also available on GitHub. Books, there's actually, I think, another one in the works right now, Kotlin for Android developers, and this is by my colleagues, which is now finished in terms of text, and it should be published soon, but it's in the early access program. I've just finished 9 hours of this is my self-promotion, forgive me. I've finished just 9 hours of Kotlin O'Reilly course, which should be available sometime in November on Safari. And community, very active community on Slack. There's just now, this snapshot was taken, 4,364 members already. We've got forums, Twitter, all of those. So if you start with it, come to the Kotlin Slack, because you will get help there as well as on our forums. So to summarize, we try to create a very pragmatic language that has a very easy learning curve. It interoperates with Java, so it provides a low-risk adoption. You don't have to limit it to tests. You can just mix and match classes. In fact, if you use IntelliJ, you can take a Java class and through a keyboard action, convert it to Kotlin code. It's not the most idiomatic Kotlin code, but it does give you a starting point. And obviously, this is subjective, but coming from C#, having stayed away from Java, I do find it enjoyable. And this is kind of something like when people say to me, you know, why should I use IntelliJ over Eclipse? I'm like, try it. If it suits you, if you find it better for you, for your needs, then great. If not, don't. And our commitment to Kotlin is that it's here to stay because we're using it in our products, right? So the business model around Kotlin is JetBrains tooling. It is not consulting or anything like that. And I'll just finish off with this. Researched Kotlin last night and then spending the morning looking at mountains of boilerplate Java and Android Studio. I see what they did, why they did it. Yeah, that's pretty much sums up why we did it. Thank you.